Welcome, everyone. I'm Erin Gray with NumFocus. We're delighted to have you here today. We're so glad you're joining us. We hope that you'll interact with us today in the chat. So please take a moment if you have the time and introduce yourself, say hello. We're really excited for our next speaker coming up. So we're going to get started in just a moment here. Just want to let you know that we have lots of great sessions, so hopefully you'll attend lots of things today. Just a couple of notes here. If you have any questions for our speaker, please pop those into the chat, and then we'll get ourselves started. So our speaker for this session, of course, is Evan Wimpey, and Evan is an analytics professional and stand-up comedian, so a wonderful combination. And Evan has a background in statistics and economics and lots of experience analyzing data, delivering statistical models. So we're really excited to get our programming side with Python as well as our humor mixed in today too. So I'm going to go ahead and I'm going to pause my mic here and I'm going to get the recording rolling, and then I'll turn that over to you, Evan.
Perfect, Erin. Thanks so much for the introduction. Thanks, NumFocus and PyData Global for inviting me out. And thanks for everybody who came to join this session. And thanks to people in the future for watching the session. Good morning or good afternoon or whatever global time it is for you. It's the morning for me, so I'll say good morning with the most authority. A little bit of logistics here. Chat is welcome. Please share anything you'd like in the chat. There's also a little reaction button at the bottom of AirMeet. So if you want to react with a little laughing emoji anytime I say something that tickles your funny bone, I'm a comedian and I thrive off the feedback of some laughter. So I will try to be a little bit funny, and laughter means that we're doing it right. So let's share a screen here and present Python worst practices. I am an expert in this area. I've had many fights with Python. Python has won every single time, but I would like to share some of these worst practices with you. First off, I will navigate this slide. There we go. Look at that. On to the next one. Who am I? Erin gave a nice introduction, but just very quickly, I'm a couple of things. I'm an analytics professional. I build models. I have a data science and economics background, put models in production. Oftentimes I break production. I'm also a stand-up comedian. I like to tell jokes. I'm not funny enough to tell real jokes to real people, but I do like nerdy jokes. So I tell a lot of nerdy jokes to my fellow data and analytics professionals. I generate laughs with both of these. Not sure which one is more, which is a bit sad. What is this talk? This talk is a tour of worst practices in Python, and more specifically in data science within Python. So to start with a very worst practice, the bottom line, the key message of this talk is not on the slide. I'm going to get to it, but I'm going to ramble on. I want to hide the message a little bit. I don't want to be clear or upfront. So I'm going to ramble on with a little bit of a story here first. Now, you may be wondering, the conference has just started, but you've got a lot of favorited events on the schedule already, looking for a lot of fun speakers. They've got interesting backgrounds. People in data science today can have any kind of background, natural sciences, economics, who knows? Now that everybody's an AI expert, anything. You could be a fisherman yesterday and you're an AI expert today. But as a data comedian, got a very specific background. It's unique to me. It's where most comedians come from. I started in the military. Very, very comedy-friendly background. But let's see, there's a red box. How are we doing here? There we go. That's me in the military. I was not a war fighter. There were other people that fight for democracy or whatever. I was a nerd. I was not issued a weapon. I was issued an Excel spreadsheet. That's me with my Excel spreadsheet. I was a finance Marine. I actually have perfect eyesight, but I was issued glasses as well, just to try to fit the nerdy profile as best I could. And in the military, it's very rigid hierarchical model, which perhaps is why I like hierarchical modeling so much today. And I had a lot of bosses. It's just the nature of the hierarchy. One of my bosses was this guy, the Dos Equis man, or one of his doppelgangers. And it was interesting. He would always carry around a notebook, not a Jupyter notebook, not a Python notebook, but like an actual hard copy, like physical notebook. So here he is walking around with his notebook, and I would always see him writing, scribble, scratching in his notebook. And then sometimes he would come by my desk, look at my little Excel spreadsheet, and he would flip over and he would write in the back of his notebook. And I always thought it was so interesting what he was doing. So on my very last day in the military, I asked him, I said, "Hey, sir, Mr. Dos Equis man, what is it that you're doing in there?" And he showed me his notebook. And this is what was written in very, very cutesy handwriting. He had written examples that he would see when he would walk by Marines. He would see particular examples of leadership and bravery and courage and excellence. And he would write down what he saw. And I said, "Well, how come sometimes you walk past me, you flip it over and you write in the back of your notebook?" And he said, "Well, Evan, you can learn from the very best examples. And Evan, you can learn from the very worst examples. So anytime I see cowardice or selfishness or undisciplined Marines, that's a very important lesson too. And I'm filling this notebook up with ways that I can be a better leader, filling it up from the front with the good examples and from the back with the bad examples." And that really resonated with me. I thought that was very important. And as we're here in PyData Global, you have access to a lot of brilliant speakers. They're sharing with you some really great tips. They're helping you fill up the front of your notebook with really great use cases. I'm going to help you fill up the back of your notebook. Okay, that's my goal here, is to give you something that is helpful and is useful by showing you what not to do. So the agenda for the rest of this time is a tour of some terrible habits, and then I'll pull up an actual notebook, not a handwritten notebook, but an actual Jupyter notebook, and we'll walk through some actual examples of where I've broken things. All right, very high level core principle of what makes good worst practice is anytime that we can just lean on some tool or some algorithm, anything we can do to outsource our human judgment. We don't want to have to think. We don't have to work too hard. We want to just be able to use the tools at our disposal. So I see that as three main ways that we can do it. The first is math. Math is fundamental. We all saw that in our elementary classrooms. You just add up the numbers. There's no context necessary. If you're doing math, you can't do it wrong. Just use a calculator. Second principle is data is more powerful than reality. We have to trust the data. We've all heard that. And the last thing is that the metrics are the king. We don't really need any contextual understanding. We just need our metrics to look good. All right, so a bit deeper, math. The first thing at the top of all of your Python notebooks that you've ever built is import NumPy as NP. Or if you're using real worst practices, you import NumPy as something else. And it's really, really worst practice. But math is great. Math is what sets us data science folks apart from our business stakeholders who just don't get it. We're running math formulas. It makes us feel smart. It makes us feel smug and superior. And it gives us a nice defense anytime our business stakeholders say, where'd that number come from? No, that can't be right. There's no 4,000% discount. Well, excuse me, it is right because we used math. And math isn't wrong. You're not going to go challenge Isaac Newton. You probably just don't get it. So we can lean on math. It's more important than any meaning or context. Trust the algorithm. Second principle is, how many times have we heard people say, trust the data? You just have to trust the data. Well, we should trust the data in fully, wholeheartedly, 100% trust the data. Forget reality in the context that some people think they may know. We want to outsource our human judgment and only have to trust the data. Now, we're humans, we're visual creatures. We generally like to plot the data, get a nice visualization. And sometimes we share a plot. We've got domain knowledge, we've got context, or our business stakeholders do, but we don't want to let that domain knowledge interfere with the type of graph we've concocted. If we can craft something that will tell the story that we want to tell, then that's what we should rely on. And humans are so good at telling stories, we can find a story in anything. If you look at a cloud, if it's sunny where you are right now, go ahead and look up at a cloud. I bet you can make a shape out of it. It is an elephant, a dinosaur, a circus tent. We're humans. We can find some signal in any kind of noise there is. So we just make up our own story based on what the data looks like to us. All right. And principle C is that metrics are the king. Metrics are much more important than understanding. But in a twist of irony here, it's important to understand what I mean by metrics. Okay. A good metric is not something that we report on to be a window to truth. It is not some perfect representation of what is actually happening in our data or our model. A metric is a shield. We use it to hide behind. We use it as a defense mechanism. We find a metric that works, that looks good for our model. We can always game some kind of metric. So maybe you're doing some forecasting. Maybe we can look at MAPE, or that doesn't work. Or maybe we look at May or SMAPE. Or if none of these off-the-shelf metrics work, this is where we exercise some human creativity, some human judgment. We can find a metric where our model or our data is going to look exactly like we want. And here's the biggest worst practice that I see people not following is if a metric looks good, if you've got the answer that you want, then you can stop digging. You don't need to interrogate it. You don't need to work anymore. You need to trust that metric and send it forward to make whatever decision it is that you want. Once you've got a good metric, your work as a data scientist is done. All right. So these are our three general principles. Sometimes it's hard to go from the generalized to the specific. So I'm going to pull up a live demo here in a Jupyter notebook, not one of those handwritten ones. And these are actual real mistakes that have actually happened in the real world to not to me personally, but this guy I know, he did all these mistakes. So let's see if I can do another mistake. And oh no, look at this. We see this. I think we see this. Comment if you can't see a Jupyter notebook here. And I'm going to walk through this Jupyter notebook. Now, there's no back or front to this notebook, but just ensure that this notebook, if you take any of this code, you copy it to the metaphorical back of your notebook of best practices. Okay. These are the things that you want to make sure that you don't do. And I will let you know that these are actual examples. Now, they've been tweaked. This is not real data. I'm embroiled in so many lawsuits now for libel and other scandalous activities. It's not worth it to me to try to use the actual data. So I've generated some data, but these are based on real scenarios that we've seen in the real world. So the point really remains that these are examples of worst practices in action. I will also like to point out that I've put several Easter eggs of bad Python into this notebook. So as you're reading through I won't go line by line through the code, but as you're reading through code or comments, note some fun Easter eggs that are some bad Python practices in there. I've tried to focus mostly on bad analytics, but there's plenty of bad Python practices as well. Let's see. Here we go. Example 1. I see in the chat, I don't have a link to this now. I'll host it on my own GitHub repo a bit later, but I will share that out to the NumFocus and the conference folks, so you can get a copy of this notebook to put in the back of your notebook. All right, here's example 1. Math is more important than meeting. Okay, what's the context here? We're a transportation company. We deal with shipping lanes, and the thing is, we've seen a huge uptick in traffic, and our shipping companies are getting very frustrated at how much time they spend in here, and we need to route them in a smarter way. So we've got snapshot sensor data from these ships that are in our area. Every single minute, we're collecting information about each of these ships. Now, that's a lot of data. At the minute level, that's a lot. That's too much for me to read, but don't worry, we can find a way to smartly aggregate that data. That's math, so you can't argue with that. So don't worry, math can make it easier. This code is just going to mimic some data. We've got a random day here from last year, and we've got a ship, and we're collecting some sensor data from it. We're collecting the most important things we've got here is for the ship at any given time. How fast is it going? That's from our sensor data. And what's its heading? And our heading is in degrees. So anywhere from, if we're looking down at the ocean, then we've got north is 0 degrees, all the way around south is 180, and then back up to north is 360 degrees and 0 degrees. The duality of north. So here we go. We've just got a couple of ships we're going to create nice data frames here for. One is our ship east, and then another is our ship confused. So we just run this and we get a cool data frame that looks like this, where for each minute, here's 8 o'clock, 8:01, 8:02, 8:03. We're collecting information about this ship. So ship east, it's going this fast, and it's going at this heading. We can see in this minute, it changed direction a little bit. It was going 90 degrees east to 95, a little bit south of east. And this is a little bit interesting. Its load, how much tonnage it's carrying. It's carrying so much weight, it's unbelievable. And it's changing a lot minute by minute. Okay, that's an artifact of bad synthetic data. But we've got this data here. The thing is, what are we supposed to do at the minute level? Every minute, this is too much, it's too fast. We just can't figure it out. At least I can't figure it out. But don't worry, we can aggregate it to the hourly level. That makes it a lot easier to see in general, where are our ships going? A lot easier to deal with in the minute level, and we're only using math. Okay, we're not doing it wrong as long as math is being calculated correctly. So here we're aggregating it to the hourly level. We've got this nice little pandas function here. We can group by and aggregate. So for each ship on the hour, we're just averaging the speed, the tons, and the heading, so the direction that it's going. Then what we get is this new hourly data frame that has each of our 2 ships. We've only got 1 hour of data for each ship, so that's fine, just 2 rows here. We've got a confused ship. In the 9 o'clock hour, it averaged 10.8 knots. Knots is some nautical mile per hour, and a lot of weight. I don't know how many, that's a lot of tons. And then its heading is 180 degrees. So it's going about due south. And ship east is going a little bit faster. It's headed about due east. So then we're just going to print this. And here's the average heading of each ship over that hourly period. Now, we want to look at the humans are visual creatures. We want to look at this. We've got a helper function here that is going to plot the vectors, so the direction, the heading that the ship is going. It's going to plot each individual vector of direction over the hour-long period, and then it's going to plot the hourly heading once we aggregate over the hour. So here we go for our east ship. We plot at each blue line is what it was recorded at each individual minute, and then the red line here is the average heading. We've aggregated it. We've made it easier to use thanks to math. Great work. Then you can see it sort of averages out over this direction. Makes it much easier to deal with. Now our confused ship, we can see each of the blue lines is its heading in the minute. And then once we average all of these blue lines together, then we get this red line, which is the exact opposite direction that the ship is going. Of course, this is correct because we used math, and a simple average or mean, as the mathematician calls it, cannot be wrong. Now, you will note that if you average 1 degree, a heading of 1 degree, and a heading of 359 degrees, you average those two, you get 180 degrees, which is the exact opposite direction. So this was particularly useful as a way to use math to make this problem much more solvable. And then here's an image of a captain that we helped route to a more efficient way to get to where he's going. He ended up in Antarctica. I believe he's still marooned there today. So math is more important than understanding. A real world problem that was solved with math. Our next example, how are we doing on time? Okay, we'll go a little quicker through these. Our next example, the data is more important than reality. Now, this is another very real scenario. involving doctors. Doctors are super smart, like really the smartest people there are. And I mean, not PhDs like you're going to hear from here at PyData Global, but actual doctors like surgeons, that do surgery on people. And so there's this head surgeon at a hospital group, and he wants a data analyst to come in and do some work to find some trends over the past few years. The analyst would present it, and the head surgeon would talk through what's changing at the hospital. So here we go. We're synthesizing a bunch of, this is not real data, but this is similar to the actual data that was seen. What we've got it looks like this. For each quarter, we've got a few metrics that show how well the hospital is doing across various places. And then we're going to plot each of these. And the way this worked was the data analyst would share this plot, and the head surgeon would speak to the group of surgeons that was there. Here's post-op complications. So after an operation, there's some percentage of patients, that have a complication. They need to come back into the hospital, be seen again. We can see the complication rate was around 14%, and then we see it dip down to around 6%. And the head surgeon was told a very clear story about what happened here. Well, of course, we adopted a new set of procedures that it allowed us to follow through, almost like a manual, a checklist for this surgery, and we're able to see this complication rate decrease. We've got nurse retention over time. What percentage of our nurses are staying with us month over month? And we see this has increased a lot. Of course, the head surgeon had the stories to tell about this. Well, we've increased nurse benefits, and we've allowed this training program so that nurses can continue on their career development, and we can see how well that's improved retention. And then we can see for this procedure that was very popular in the hospital, what's the recovery time like? Well, look, once we implemented the new training plan, here we can see that we started to reduce the recovery time, and that's because all of our junior physicians were able to do the procedure with best practices in mind. Well, it was about this time that somebody noticed something, and the head surgeon had these great stories to tell. Everybody was very excited. We were in a radiology department, and when you present in the radiology conference room, they're used to presenting things like this. It's an x-ray. I believe this is an ankle or a foot. But if you're not a radiologist, then you may not be aware, but each x-ray that gets presented, the way it's taken, when it's presented, it's flipped on its horizontal axis, so we can see the actual view of the patient. Now, when the head surgeon was presenting this, somebody pointed out, how come the horizontal axis is flipped here? Because if we look, this is actually 2022 Q1, and over here is 2024. So this is going backwards in time. So the analyst quickly switched the presentation mode to go forward. And now we're seeing the actual results instead of the horizontally flipped results. So what we've got is a complication rate that is gone in 2022 from around 6% to now 14%. Now, this may look like a very critical error. How are we going to recover from this? But don't worry, the head surgeon is an actual head surgeon in a hospital group, immediately had a story to tell for this line, just like he had to tell for the line that was decreasing instead of increasing. Well, of course, the complication rate's going up over time. This is in the post-COVID world, where our patients are much less healthy on average, with way more comorbidities than they would have had previously to this. So that's why we see the complication rate go up. And the nurse retention rate over time. Well, of course, the retention rate is going down. The housing in this area is outrageously expensive. And in the post-COVID, nationwide, we're seeing more nurse turnover. So that's why we see the retention rate go down. And the recovery time. Well, yes, we have much more junior physicians now than we used to. We've lost all our senior physicians, so we don't perform the procedure as well. And the recovery time is longer. So the fact that the human, the most context-aware medical doctor, head surgeon at a hospital group, has a story, and then as soon as the data reflects something else, they immediately invent a story that will follow that as well. That's good worst practices. All right, our last one here, example C, is that metrics are more important than understanding. So this is an industrial manufacturer. They make big steel, metal industrial things. I don't know. Anyways, you wouldn't understand. But they ship it all over the world, and sometimes it gets there late. Actually, most of the time it gets there late. But they hire a fancy pants data scientist to come in and say, hey, how come some of these shipments arrive late? And so the fancy pants data scientist comes in, and like all good causal models, they just used scikit-learn, a decision tree classifier, which of course will tell us why the shipments are late. So we're making up the data, but we're just grabbing 150 random orders, and then these types of features that we know for each order, which the logistics, the manufacturer had in their logistics data. So we know if it's a priority order, if it's a fragile item, was it international, what was the supplier or carrier like? And then what we've got is this data set where for each order, we know all of these features about it. And what we ultimately care about is this flag right here. Is it late or is it not? So this order was late, this is not, this was not, this one was late. So we asked the data scientist, what's driving these late orders? But we don't actually have this data set. This is an aggregated data set. What we actually have is this data set at the date level, the date and order level. So for each order, every day it was open, we've got this date, the January 9th, January 10th, 11th, and we've got all the same detail about each order, but it's open for multiple days. And of course, if it was late, regardless of which day. So this right here, this is why data scientists make the big bucks. Okay, this is the only thing data scientists do with their time is right here: train, test, model, fit. That's all we care about. Now, of course, we've got a date in our data set. Scikit-learn doesn't want this date time to be a predictor, but that's okay. We can make a string date. Turns out it doesn't want to use a string date either, so we have to actually factorize it. But don't worry, we're going to use date as a predictor. So we do this. We randomly split. There's no leakage between train and test. We want to see how well it does on test data. So we randomly split. We get 1,500 rows in train, 500 in test, and we build our model. Look at this. The train accuracy is 100%. The test accuracy is 99.4%. We're doing good. We're doing fantastic. If we look at the importance, this is what the data science cares about, right? What's
Hey,
driving
Evan. Sorry, I just gonna pop in real fast and let you know that you have 2 minutes left in your presentation.
Oh, goodness. Okay. Well, then we will just leave it as an exercise to the reader why this model is so fantastically good. But don't worry, we've got a test accuracy of 99%. And we'll see if anybody can put in the chat why it was maybe if we split on this, randomly split on this data set here. If you're a true worst practicer of Python, then hopefully you can find out why. All right, that's our live demo. In good worst practices, I'm making sure to go over time here. I will try to wrap it up into something a little bit serious and useful here. I'm a data comedian. I try to make jokes about these types of things all the time. We laugh at these bad habits, but we do it in a way that we can learn. We do it so we can spot them in the wild. I put up some pretty egregious errors here, but these are the types of things that we see in data science all of the time. And sometimes we do them ourselves and we may not even realize it. So the more we're able to sort of poke fun at these types of things, the more we may be able to recognize problems like this when they pop up in actual data science. And hopefully being able to laugh at a little bit makes it more fun for you and a little bit less humiliating when you find yourself making a mistake like this. I can navigate the slides here, can I? Oh, yeah, this is me. This is me in 4 pixels and predictablejokes.com. If you enjoy data science, some nerdy comedy where we can come poke fun at things like this, then please reach out or follow along. And I'm trying to make folks laugh all of the time. Hopefully you made you laugh today, and hopefully you learned a little something too. Thanks everybody for coming to join.
Thank you, Evan. Thank you, everybody.